Today, we're soaring into the world of aviation safety, specifically a concept called damage tolerance. It's basically how airplanes are designed to, well, tolerate damage, stay safe, even with a few bumps and bruises.
Makes sense. So, they can handle a bit of rough handling.
In a way, yeah, it's not about flying with gaping holes, of course, but more like understanding how those inevitable minor cracks or dents affect the plane structure and making sure it can still fly safely.
I see. So, a little crack in a windshield, that doesn't mean the whole thing's going to shatter.
That's a great example. The glass is designed to kind of hold itself together, preventing that crack from becoming a bigger problem.
Pretty clever. So, how do they apply that to a whole airplane? I mean, it's a lot more complex than a windshield.
It is, but the principle's the same. Damage tolerance is factored into every part of the design, from the wings to the fuselage, even the landing gear.
Okay, I'm starting to get it. So, if you think about a bicycle frame, a little dent doesn't mean it's going to collapse.
Frame's built to absorb that impact,
Yep.
distribute the stress.
Right. But airplanes go through much more than a bicycle, especially during takeoff and landing, all those forces.
Absolutely. And those repeated stresses can lead to something called fatigue.
Fatigue, like when I'm tired after a long flight.
Well, similar concept, but for metal. It's like bending a paper clip back and forth. Eventually it'll snap, even if each bend seems tiny.
So how do they deal with fatigue in airplanes? Do they just replace parts before they get too tired?
It's a bit more involved than that. They use something called stress cycles, a way to measure how much stress a part experiences over time. Knowing that, they can predict when it might need attention.
So it's like they have a schedule for each part based on how much stress it goes through?
They're basically predicting when a part might need some TLC. But then there are those unexpected things like a bird strike or hail damage. How do they plan for that?
That's where redundancy comes in. Airplanes have backup systems for crucial parts. Like if one hydraulic system fails, another can take over.
So there's always a plan B. That's reassuring. But how do they make sure those backup systems are actually ready to go when needed?
Regular checkups, just like going to the doctor. Even if you feel fine, it's good to get things checked out. Those inspections let them find any issues early on.
So it's a combo of smart design, those regular checkups, and I'm guessing using really tough materials.
You got it. Airplanes are built with some seriously strong stuff like aluminum alloys and titanium. They can handle a lot of stress, resist cracks, and even corrosion.
So it's not just any old metal they're slapping together.
Definitely not.
Wow, that's incredible. They've really thought of everything to keep those planes in the air.
Absolutely. That's damage tolerance in a nutshell, anticipating problems, designing for resilience, and making sure those planes stay safe up there.
Okay, so we've covered how damage tolerance keeps planes flying safe, even with those little issues that pop up. But here's something I've always wondered. If airplanes are designed to be so tough, why do they eventually have to retire?
That's a good question. It's not just about fixing a dent or replacing a part. There's more to it than that.
So it's not like a car where you can just keep fixing it up forever.
Not exactly. You see, one major factor is what's called widespread fatigue damage.
Widespread fatigue damage. Sounds intense.
It is. It's the result of all those stresses an airplane experiences over countless flights. All those pressurizations, vibrations, landings, it all adds up.
So even with those regular checkups and repairs, the plane's structure itself gets worn down over time.
Right. It's like imagine bending a metal spoon over and over again. Eventually it'll weaken and break, even if you can't see any obvious cracks.
That's a little unsettling. So are you saying there are microscopic cracks forming within the material?
Exactly. And those tiny cracks can compromise the overall strength of the aircraft?
So it's a matter of cost effectiveness as much as safety.
Yes, precisely. Replacing large sections of a plane would be incredibly expensive and time-consuming. Sometimes it makes more sense to invest in newer, more advanced aircraft.
Makes sense. But is fatigue the only thing that sends a plane into retirement?
No, there are other factors too. Corrosion, for example, plays a big role.
Corrosion. Like rust.
Similar idea. Exposure to moisture, salt air, even de-icing fluids can gradually corrode the metal, even with protective coatings.
So it's like rust slowly eating away at a car, even if you try to keep it clean.
Exactly. And the tricky thing about corrosion is that it often starts in those hard-to-reach places, making it tough to spot early on.
I could see how that would be a challenge for the maintenance crews. Are there ways to prevent that kind of hidden corrosion?
Airlines do use special coatings and thorough inspections to minimize it, but it's a constant battle against the elements.
Wow, so much goes into keeping those planes in tip-top shape. It's like a race against time and the elements.
It really is. And then on top of all that, you also have to consider advancements in technology and changing regulations.
So even if a plane is structurally sound, it might become outdated.
Exactly. It might lack the latest safety features or fuel efficiency standards. Sometimes retiring a plane is about making way for newer, more efficient, and even safer models.
It's kind of like our smartphones. We might love our old ones, but eventually they get outdated and it's time for an upgrade.
Perfect analogy. So when we hear about an airplane's retirement age, it's not just about how much damage it can handle. It's a complex equation with a lot of variables.
Definitely a lot more to it than meets the eye.
So it sounds like this retirement age is constantly evolving as technology advances and we learn more about aircraft aging. It's a constant process of refining and improving our understanding of how to keep planes flying safely and efficiently.
It's pretty amazing to think about all the factors that go into keeping us safe in the air. It makes you realize just how complex and sophisticated the aviation industry really is.
It is complex, but remember, safety is always the top priority. They're constantly monitoring, researching, and implementing new strategies to address these aging factors. So when you board that plane, you can be confident that you're stepping onto a marvel of engineering that's been carefully designed, tested, and maintained to the highest standards.
We've talked about how planes are built to last, but what about the future? What's next for keeping those birds flying high?
There are some incredible innovations coming down the pipeline.
Okay, give me a sneak peek. What kind of futuristic tech are we talking about?
Well, one thing that's getting everyone excited is self-healing materials.
Self-healing materials. That sounds like science fiction.
I know, right? It's like something out of a movie. But scientists are actually working on materials that can repair themselves.
Hold on, how is that even possible?
Now, picture this. Tiny capsules embedded in the material release a healing agent when a crack appears.
Wow. So it's like the airplane has its own little repair kit, always on standby.
Exactly. These self-healing materials could really change the game, cutting down on repairs and making planes last even longer.
It's like those small cuts we get that just heal up on their own. But like for an airplane, what else is on the horizon?
Another game changer, advanced sensors and data analysis. Imagine airplanes covered in sensors, constantly monitoring their health.
So it's like giving the plane a nervous system that can feel when something's wrong.
Yeah, you got it. All that data can then be analyzed to predict potential problems before they even happen.
That's incredible. It's like having a crystal ball for airplane maintenance, predicting the future of wear and tear.
Right, it's all about staying ahead of the curve. Oh, and speaking of futuristic, 3D printing is also becoming a big deal in aviation.
3D printed airplanes.
Yeah. Imagine printing entire aircraft components on demand, right when and where you need them. It could revolutionize manufacturing.
Wow, talk about streamlining things. But how does that impact safety and reliability?
Well, with 3D printing, you can create super complex and customized parts, leading to potentially lighter and stronger aircraft.
So it's not just about speed and convenience, it's about pushing the limits of what's possible with aircraft design.
Exactly. And who knows, maybe one day we'll even see mid-flight 3D printing for emergency repairs.
Now that's what I call thinking outside the box.
Yeah.
Okay, so the future of aviation is smarter materials, predictive maintenance, and on-demand manufacturing.
You got it. It's all about combining those cutting-edge technologies to make flying safer, more efficient, and even more sustainable.
This has been an awesome journey into the world of damage tolerance and the future of aviation. It's incredible how far we've come, from those early days of flight to these mind-blowing advancements. It's reassuring to know how much effort goes in to making sure every flight is as safe as possible.
Absolutely. And as we keep pushing the boundaries of what's possible, one thing's for sure, our commitment to safety and innovation in aviation will never waver.
So, next time you're on a plane, take a moment to appreciate the incredible technology and expertise that goes into getting you from point A to point B. It's truly a marvel of engineering. And with those self-healing materials and predictive maintenance, the future of flying is looking brighter than ever.